All right, so you have 4 bottles in front of you. 2 of them are empty, and 2 have nice cold water. Okay? This is a beaker of hot water, and I'm going to pour the hot water into the remaining 2 bottles. Need to make sure that this water is all the way to the top. Now, the first interesting thing we're going to look at is what happens to food coloring when you add it to hot water. I'm going to start with the cold versus hot. And the first thing you'll notice is that the food coloring is moving faster in the hot water. That's an interesting question, isn't it? As to why it's moving faster in the hot water. Now comes the fun part. I'm going to take the cold water and put it over the hot water. And let's see what happens. This is a flimsy piece of wax paper. Going to pray to the chemistry gods that are out there. This is cold over hot. Now comes the fun one. This one's hot. I'm going to have to use my gloves. It's so hot. Flimsy piece of wax paper. One of the mysteries we have to solve is how in the world a flimsy piece of wax paper could possibly hold that much water. This is hot over cold. Notice that cold over hot very quickly mixed throughout. This was cold and this was hot. I feel it, and this is now warmish. And this is now hotter. So this was cold and this is hot. Now this is warm, and this one is actually warmer than the bottom one. This was cold. Ow. This was hot. It's still cold. And it's still hot. Very interesting. By tomorrow, what would you expect this one to look like? One day later. All right, these are pictures of what these things would look like if you could see them microscopically, if you can see the molecules. These are not accurate pictures. They're a bit of an exaggeration, but it helps us understand what is going on here. So, first thing we need to do is remember the concept of kinetic theory that you probably first heard of in middle school. The hotter the molecules, the faster they will move. The colder the molecules, the slower they will move. So on the left side, you have hot over cold. Notice that the cold molecules are not moving they're closer packed together because they can't move very far. The hot molecules are moving very fast, bouncing into each other, and they're going to spread out. So once again, this is a bit of an exaggeration, but not too much. you can see that the hotter molecules are further apart. There's a lot of empty space between them. The colder molecules are closer together. So we can say that hotter water molecules are going to be less dense. There's less of them in the same volume as the colder, more dense molecules. So what you have here is hot, less dense over cold, more dense. Now, this concept is going to rule many facets of our lives, and I'll explain it here in a second. First of all, can you kind of see why the hot water never got into the cold water? Well, where? Where are they going to fit? There's no room. There is no room between the molecules. But what about cold over hot? Yes, these molecules will come down and start accumulating down in the bottom. These molecules are still going to be relatively cold. And what do they start doing to the hot molecules as they start accumulating down in the bottom? Yes, they will start pushing these guys up so that within just a few seconds, they will look more like this one, with the cold water down on the bottom and the hot water on top. Now, why is it that after a day or so, everyone's green? Can you guess? Well, what happens to energy? First law of thermodynamics. Energy keeps flowing until everyone has the same temperature. So after everyone has the same temperature, then there is no hot, there is no cold. Every molecule has the same temperature. Therefore, the green food coloring is going to be uniformly spread out. Now, why is this practical to us? Well, think of your house. Let's say there's a top floor and there's a bottom floor. Okay? During the winter months, as soon as you open the door, cold, very dense air is going to flow in. What's it going to do to your hot, warm air, your less dense air that your heating system is doing such a good job of making? Well, it's going to push it up. So the hot air is going to go up to the second floor. The cold air is going to be in the bottom floor. Okay? So what do you have to do? Well, if your mom or dad know this, understand this concept, then what they're going to do is they're going to open the vents here at the bottom level. Since you know that hot air is going to go up anyway, you open your vents in order for your heating system to bring in the hot air to the bottom floor. You close the vents to the top floor so that the hot air doesn't go to the top floor. Because think about it. If the hot air goes to the top floor, then as that hot air is pushed up by the cooler air, it gets to go and heat up the air in your attic where no one lives. So if you close the vents to your top floor, you're going to force all the hot air to come into your bottom floor. Eventually, that hot air is going to go up into the second floor anyway. So voila, you can easily heat your home during the winter months. Now, what happens during the summer months? All right. So during the summer months, you've got hot air outside, and as soon as you open the door, the hot air is going to come in. Okay? And that hot air is, of course, going to want to make its way up to the second floor because it is less dense. It's going to be pushed up to the second floor by the cooler air that you are creating by having your air conditioner on. So what should you do? Well, think about it. You want the second floor automatically is going to be warmer than normal because every time you open the door, you let hot air in and the air goes outside. So you're going to want to open the vents up top, letting the cool air come in order to cool down the air, the hot air that is moving up from the bottom floor. And you're going to want to close these vents. Okay, naturally, the bottom floor, whether that's your basement or your first floor, is naturally going to be cooler. So as this cool air is brought in to the top floor, it's going to flow on down through your stairs, through any openings that are in your house. So during the summer, you cool your top floor. During the winter, you heat your bottom floor. And that's what you should be doing with your vents. You also have ceiling fans. And if the ceiling fan is designed in such a way that if it's moving in a certain direction, it's pushing air down. If it's moving in the opposite direction, it's pushing air up. So during the summer months, you want to be drawing the air up, the hot air up. So it's going to be spinning in a certain direction. You may have to Google which direction you want it to spin. But during the winter months, it needs to be spinning in the opposite direction in order to push the warm air back down to where you are. Now, hot air balloons are going to work in a similar way. And we'll talk more about that when we get to gas laws. Also, our weather systems are based on this same principle. Hot air is going to be less dense, cold air is going to be more dense. So these masses of air are always interacting. That's what causes rainstorms, that's what causes cold and warm fronts, that's what causes clear skies and cloudy skies. Now, as to the explanation of how I was able to invert a full bottle of water and have it held in place by a flimsy piece of wax paper, here's the explanation. First of all, it has to be wax paper. Wax paper is made up of a material that water is repelled by. Water is not going to be attracted to this. Water is very sticky, so it likes to stick to things, and if it can't stick to things, it'll stick to itself. So wax paper is not sticky at all. So water can't stick to it. So they will have a tendency to want to stick to themselves. So what are the forces that are at work here? You have gravity pulling the water molecules down. You have the force of water molecules being attracted to each other and sticking to themselves. And then you have one final force that you can't see, but it is there. And that is air molecules pushing up against that piece of wax paper. The reason why the water molecules do not come down is because they are so sticky, they will stick to themselves with such tenacity that stickiness plus air pushing up is enough to counteract the effect of gravity. So that piece of wax paper will prevent the water from coming out for an indeterminate period of time. As long as you're holding the bottle just right, it will not allow the water to come down. Now, if you start tilting it, then you have unequal forces and you may poke through that piece of wax paper. So air pressure is what is sealing that that piece of wax paper onto the bottle full of water.